Hello. In this session, we will solve a Laplace equation over a rectangular domain. So, when you have a domain of this type, that means a rectangular domain, okay, and then you can apply this method to solve a Laplace equation. Okay, so we will basically consider a rectangular domain here. So you can see this point should be your x. Okay, this is your a basically, not x. This is 0, and that's my point b. Okay, and it goes on. Fine. 0, then this is my x-axis and this is my y-axis. So suppose you have a Laplace equation to solve this. This is nothing but partial derivative of u with respect to x. Most of the time we can even write down by this method. Square u upon del x square plus del square u upon del y square equal to 0. Okay. When we have an equation of this type, then we can find them in which category it belongs. So basically based on the problems that we have seen, we have described into 4 categories. So let me explain you by a table, okay, in which 4 categories this will belong. So basically first we should see that how many conditions are needed here. So 2 conditions for this and 2 conditions for this. So we need mostly 4 conditions, okay, 4 initial or boundary conditions. So let's see. Okay, now let me explain the type. Okay, so we have here type 1, type 2, and then type 3, and then type 4. And so we have got mainly 4 types of Laplace equation. Okay, Laplace equation will be same, only the thing that will differ is just the boundary conditions. Okay, so I'll explain you the boundary conditions. So here is your ux0, okay, and then uxb, and then goes u0y, and then u of a comma y. Okay. So that's how it will be defined. And now when you have ux0 defined to be some f of x and rest of them are 0, okay, rest of them are 0, that means rest of them uxb is 0 and u0y is 0, uay is 0. So that mainly forms type 1. Okay, only ux0 is defined and rest of them are 0 on the boundaries. Okay, so that's type 1 basically. And similarly I'll define type 2, where I'll impose condition on uxb as some g of x. Okay, or even if you take f of x, that's perfectly fine. So in this case we will take f of x only, okay, just for simplicity, because whenever we are dealing with x, so I'll take f, and when we are dealing with y, then I'll take g. Okay, and rest of the conditions are 0. It means ux0 is also 0 and u0 is 0, and this quantity is again 0. Fine, so that forms a type 2. And similarly I'll take one more. Here I'll impose condition on 0, a function of 0 comma y will be some gy, and I'll fix all other conditions to be 0. Okay, means ux0 will be 0, uxb 0, and u0y some g of y, and uay 0. Fine, that contributes my type 3. And now comes 4. In 4 I'll simply fix uay equal to some function of gy, and then rest of the conditions are 0. So mainly we have got 4 types. Okay, another solution for all these 4 types are given, okay, by a following formula that I'll be writing down. Okay, so whenever you get a problem, just weight the problem in which category it belongs and then type with that solution and then solve with that solution. Okay, so let me write down the solution for type 1. Okay, so this is your type 1. So solution for type 1. So let us say how your problem belongs. Okay, it's like uxx plus uyy equal to 0. Okay, and then you have here ux0 equal to some f of x. Okay, and rest of them are 0. uxb equal to 0 and u0y is 0, and one more condition I have to impose. Okay, let's impose here uay 0. Okay, so I've got uay 0, u0y 0, uxb 0, only ux0 is sum of x. So I have to write down the solution for this type. Okay, so remember one thing, the solution for Laplace equation is always a trigonometric function and a hyperbolic function. Okay, for all the types it is always a trigonometric function and one hyperbolic function. Fine, so only thing that we have to recognize is whenever you have a function defined in type x, okay, because it is all just type x, whenever you have a function of type x, then basically you get trigonometric function will be in x, and hyperbolic will come in y. Okay, that means what I'm saying. See here. That means when I'm writing the solution, then my solution will look like uxy will be equal to summation n equal to 1 to infinity, okay, dn times, first it will be sine, okay, n pi x upon a into sine hyperbolic, okay, n pi b minus y upon a. Okay, so that's my solution basically. And now look at this. This is what I was talking about. When you have a function given in type of x, then in trigonometric function you get sine. Okay, in trigonometric function, this is just sine. So you have here x, while hyperbolic has y. Okay, so now I'll equate this dn. Okay, so to equate this dn, you can simply say your ux0 is your f of x. Okay, ux0 is f of x. So simply equate here. Okay, you can write down to evaluate dn. We can simply say ux0 equal to f of x. So put here f of x, and then basically you get series n equal to 1 to infinity, take dn here, and then basically sine of n pi x, okay, upon a will be there, and then I get sine hyperbolic, okay, sine hyperbolic n pi, this will be b minus 0, so that is just b. Okay, so n pi b upon a. Now this f of x equal to, if I take this dn and this constant, this will be a constant. Okay, and now look at this. This basically forms a Fourier sine series. So this coefficient, that is dn times sine hyperbolic n pi b upon a will be equal to 2 upon a, then 0 to a f of x into sine n pi x upon a dx. Okay. Now, if you have seen my previous videos, then I had described how to find this dn, that's Fourier coefficient. So earlier I was using 2 upon L. So L was the length of the string there. Fine. Now since here we are dealing with X and Y both, so we have to see what is the length of the rectangle. I mean this side. Okay. So if you see the length of this X, okay, this is just A. Okay. So that's why I'm writing, whenever I'm integrating with respect to X, okay, I'm using A, and for Y I'll use B. Okay. So 2 upon A and 2 upon B simultaneously change the role whenever they are needed. Okay, so look at this. So that's why I'm, instead of L, I'm writing A. Okay, so from 2 by A to 0 to A, f of x sine n pi x. Okay, so that's your solution. Star is your solution, and this is your dn. You can even take dn to this side. Okay, but basically I'll recommend not to do so. Okay, keep it here in fact. Okay, that will play a good role. Okay, so this is the solution for type 1. Similarly, you can find a solution for all the types. Okay, and nothing much will change. Now just let me solve one more. I'll evaluate case 2 and I'll leave case 3 and case 4 to you. Okay, so let me evaluate this case 2. Okay, so solution for case 2. Solution for case 2. What is the solution for case 2? Okay, so first let me write down the case 2. Okay, it's like uxx plus uyy equal to 0, and then 0 less than or equal to x less than or equal to a, 0 less than or equal to y less than or equal to b. Okay, and then you have here ux0 is 0 this time. Okay, and uxb equal to some function of x. Okay, and then u of 0y is 0. Okay, and u of ay is also 0. Okay, now let me remind you how will you find this trigonometric solution. That means, I'm sorry, hyperbolic. You will say that, so I'm writing here n pi x upon a, while I'm writing here n pi b minus y upon a. Okay, so that will basically make a difference, because I have to evaluate this dn later on. Okay, so to find out this, then I have to use the initial condition. So I should see which initial condition. Okay, when I impose, that means if I put here 0, so if I put x comma y is 0, then I'll get a condition. So that's why I have imposed a condition on ux 0. So I'm writing here n pi b minus y. But now if you look at the second case, okay, if you look at the second case, okay, in this case here you have x comma b is f of x, means there is no need to write down this b minus y, okay, because b will remain intact there, so we don't need even. Okay, so I'll write down the solution for this quantity. See here. Okay, so solution is given by, okay, so solution is given by u x y will be equal to, okay, summation n equal to 1 to infinity dn sine n pi x upon a into sine hyperbolic n pi y upon a. Okay, so now I'll be using this condition. Okay, I'll just put y equal to b here. So for this condition, I mean using this condition I'll get this dn basically. So let us find out dn. Okay, where dn is given by, okay, so I'm writing here. Let me change the ink. Yeah, but I'm planning to club this condition together. Rather, I'll write down here, okay, so that I can use this space. Okay. Yeah. And now I need to find out this dn. So I'll use initial condition since u x b equal to some f of x. Okay. So now put here f of x. So you get f of x equal to summation n equal to 1 to infinity dn sine n pi x upon a into sine hyperbolic, oh I'm sorry, there is no space, so I'll write down below, into sine hyperbolic n pi, now it will become b, okay, upon. So our goal is to find out this, I mean the constant must be in the hyperbolic function, so I should decide where b minus y will come or a minus y will come or just b y will come. Okay, so that depends only on these conditions. Okay, now just look at this series very carefully. This is again a Fourier sine series with this constant, this coefficient in fact. So let us find out the coefficient. Okay, so where dn then sine hyperbolic n pi b upon a, okay, will be equal to 2 upon a and then integral, okay, 0 to a, and rest of the things will remain same, f of x into sine n pi x upon a and then dx. Right. This integrating between 0 to a, this 0 very wide, so rather I'll write down here. Okay, yeah, it's 2 upon a and then 0 to a f of x sine n pi x upon a dx. Okay, that's my dn. So I got solution for this type, and this dn quantity will remain same. Okay, similarly you can try for case 3 and case 4. Okay, so I'll directly write down the solution for them. Okay, because that will help us. So here comes the type 3. Okay, I'll write down the solution. Now comes type 3. Okay. Ui equal to 0 and conditions are u x naught, u x 0 equal to 0 and u x b will be 0. Okay, now I have the condition on y, so u, I'm sorry, this is 0. Okay, even if I write y, that's fine. U ay equal to 0 and u 0y, I'll impose some function, okay, some g of y. Okay, now the solution for this type will be given by, okay, solution is given by u x comma, let me write down from the very extreme end, because otherwise it will have a problem. So u x y will be equal to summation n equal to 1 to infinity, okay, 1 to infinity, now dn into sine. Now see, since the solution is question is given in y, okay, so here in trigonometric function I'll get y now, so n pi y, and when it is y, then in the denominator it will be b, okay, and then in sine hyperbolic, now I have to decide, see here, so n pi. Now look at the condition. Condition is on 0 comma y equal to g of y. So if I put x equal to 0, then I'm getting some g of y. Okay. So to use this condition, I need to put here n pi, okay, a minus x. Okay. A minus x, okay, upon b. So that will be my solution. Okay. And now using the condition u0y equal to some g of y, I'll have to substitute there. So you get g of y equal to summation n equal to 1 to infinity dn, then sine n pi y upon b times sine hyperbolic n pi. It will become x is 0, so it will be just a upon b. Now it is again a Fourier sine series where this coefficient dn and this quantity is your Fourier coefficient that will be given by dn into sine hyperbolic n pi a upon b will be given by, it will be now 2 by, we are dealing with y basically. First let me write down, okay, so you will get it better. So g of y into sine n pi y upon b dy. Since I'm dealing with dy, so I need the length of y, so length of y was b, so it will be 2 upon b and then 0 to b. Okay, so that's my dn sine hyperbolic. I got given this thing, right? And on the same lines, I can even finish the proof for this type 4. So let me complete type 4 even. Okay, type 4. Okay, now let us solve this one. So it will be same uxx plus uyy equal to 0. Let me impose the condition. So u x comma 0 will be equal to 0, and u of x comma b will be 0, and u 0 comma y will be 0, and u of a comma y, now it will be g of y. Okay, so we should be very careful here. Now condition is on a comma y. Okay, so one should be very aware that how while writing the solution for hyperbolic function, I need to check whether I'm getting here just x minus a or a minus x. So here it is a, so there is no need to go for a minus y because it's already a here, so I'll get a constant for sure. So now the solution is given by, okay, solution is given by u xy will be equal to summation n equal to 1 to infinity dn, then sine n pi y upon b into sine hyperbolic n pi, it will be just x, no, not x, n pi, yeah, n pi x upon b. Okay, because condition I have to use on a comma y. Okay, so there is no need to put here a minus y. See this, whenever you have a question in form of y, so in trigonometric it will become y, and in hyperbolic x will come. Okay, that's what the strategy is required. And now we will find out this dn. So using the condition, okay, u of a comma y is my g of y. Okay, g of y. So I'm getting here g of y will be equal to summation n equal to 1 to infinity dn, then sine n pi y upon b, and then I have sine hyperbolic. So sine hyperbolic n pi, at the place of x I'll put this, okay, a. So I'll get my condition. Okay, so a upon b. That's again a Fourier sine series, and this Fourier coefficient dn and this will be given by, okay, where dn and then sine hyperbolic n pi a upon b is equal to 2 upon b and integral 0 to b. Since I'm dealing with y, so I'll write down the length of b, length of y. Okay. So here I'll get g of y and then sine n pi y upon b dy. Okay. So now I completed solution of type 1, type 2, type 3 and type 4. Okay. Any problem if comes from Laplace, okay, then it will be in any one of the following type. Okay. And conditions are imposed, okay, whenever you get a problem based on the rectangular domain only. Okay, so this formula is true only for the rectangular domain. Suppose they gave you some circle or some ellipse, then you cannot apply this formula. Okay, so in that case, simple method would be to go by operator method that I'll teach you in my later sections. Okay, how to deal with operator sections to solve this wave equation and Laplace equation. Okay, so I hope these 4 types are clear, and now we will solve few examples in my next video. Okay, thanks for watching. Welcome. So in this session, we will solve problems based on Laplace equation. These are problems mainly asked in CSIR exam or GATE exam. Okay. So let's consider this problem. This is one of the problems from the same exam. Okay. While the question is slightly modified. Okay. So the question is uxx plus uyy is 0, and these are four conditions. Okay. The boundary conditions here. Okay, so now first we will write down these equations into the 4 types that we have seen. Okay, and let's see where it belongs to. Okay, then we can apply the solution accordingly. Right? So if you look at the boundary conditions and ux0 equal to 0, this simply means this is not of a type 1. Okay, now ux0 is 0, now ux pi. Okay, so earlier it was xb. Okay, now so x pi is here sine 2x. Okay, so this problem belongs to type 2. Okay, this is sure now, and u0y is 0 and u pi y is also 0. The condition on the boundaries are 0 and u x pi is sine 2x, right? So this is a type 2 problem, right? That's our type 2 problem. Okay. So the solution of type 2 problem. And now you should remember this is given in x. Okay, so that means trigonometric part will have x and hyperbolic part will have y. Okay, and since the condition is at x comma pi, so there is no need to take a minus y, okay, in the solution. So uxy will be equal to summation n equal to 1 to infinity, okay, dn sine n pi x upon it is given in y, so it will be a what, something is wrong with this, n pi upon a, yeah, and then sine hyperbolic n pi, it will be simply y, okay, upon a. Okay, so now let us solve this. And if you wonder how I got this solutions, just look at the previous slide in type 2. Okay, yeah, here is the solution for type 2. Okay, you can say this n pi x upon a and then sine hyperbolic n pi y upon a. Now let us find out our dn and equate the problem, okay, where this dn thing is given by, now first let me use the condition first. What is the condition there? U x comma pi is sine 2x. Okay, so let's apply that. Since u x comma pi is my sine 2x, okay, now solution is given by uxy equal to summation. The more you practice for the writing solution, the more you understand this. Okay, dn and then sine n pi x upon a, then sine hyperbolic n pi y upon a. Okay, so let's apply this at the place of a y. I'll put pi. Okay, so u of, yeah, and we notice that a is also pi. Okay, a is also here pi in our case. Okay, a, this is always u of x comma Okay, a is pi, so we'll be getting this quantity getting cancelled. Or you can even write down the solution like this. Okay, that is nothing but summation n equal to 1 to infinity dn sine, since a is pi, so this pi and this pi will get cancelled, you just get nx, and then sine hyperbolic, this again pi pi gets cancelled, you get just n y. Okay, so we will use this solution in fact, okay, for our calculations. So let me simply remove this bigger a and this pi. Okay. So this is not needed now. In case if you write down, then also there is no problem, because ultimately it will get cancelled for sure. Okay, if you don't believe, just check it, don't worry. Okay, yeah, go for this. So now u of x comma pi, okay, even if you put here, so you are getting basically n equal to 1 to infinity dn, and then sine, at least I can put it now, so n pi x upon a is also pi, and then sine hyperbolic n pi. Now I need y, but at the place of y I have here pi, so it will be pi upon a is also pi. So this pi get cancelled, and this pi will get cancelled. I'll be left with n equal to 1 to infinity dn sine nx into sine hyperbolic n pi. Now this coefficient is given by dn, okay, sine hyperbolic n pi is nothing but 2 upon c. I'll basically tell you how to write down. I have in the function in the form of x, okay, so f of x into sine, I still have here nx, okay, and I'm integrating with respect to x, so I need the length of x, so length of x is also a, so it will be 0 to pi and then 2 upon pi. Okay, now it will be 2 upon pi, then integral 0 to pi. My f of x is sine 2x. Okay, this is my f of x. Okay, that's sine 2x. So let's plug in there. So it will be sine 2x and then sine nx dx. Okay, so now dn and then sine hyperbolic n pi. And now we know the formula for this. This exists, I mean, equals 0 when these two are not equal, and when n is same as 2, then I'll get here pi by 2. Okay, basically I'm talking about this formula, though I have already mentioned, but still I'll mention this for your reference. I'm talking about this formula. It's basically 0 to pi sine mx into sine nx. This is equal to either 0 or pi by 2. Okay, when m is not n, then it is 0, and when m is equal to n, this is pi by 2. Okay, so now I know that this here is 2 and this here is n, so I'll find only d2. Okay, because the rest of the things will be 0, so let's find out d2 here. Okay, because all other terms will not survive, so I'll get here d2 sine hyperbolic 2 pi will be equal to 2 upon pi, yeah, 2 upon pi into pi by 2. Okay, so 2 upon pi into, this is pi by 2, so I'll just get here 1. So my dn would be equal to not dn, yeah, dn will be 0 except for n not equal to 2, because d2 will be equal to 1 upon sine hyperbolic 2 pi. Okay, so now let's plug it into the solution. Okay, so my uxy is nothing but summation, and not summation in fact, but still I'll mention this, n equal to 1 to infinity dn sine nx and then sine hyperbolic n y. Okay, and we found only this d1, d2 will survive, so I'll open this and rest of them will get 0, so I'll remain with d2 only simply. So that will give me sine 2x and then sine hyperbolic 2y. Okay, so that's my u of xy. Okay. And I'll simply just plug in what is d2 here. Okay, so I'll be getting uxy will be equal to 1 upon sine hyperbolic 2 pi into sine 2x and then sine hyperbolic 2y. This is my required solution. Okay, is the required solution. But now we have one more way to go. Okay, they are asking us what is u of, I think they are asked what is u of pi by 4 comma pi, pi by 4 comma pi. But they are asking u of pi by 4 comma pi is what? So at the place of x, just put pi by 4 here, and at the place of y, just put pi. So basically I'll be getting, okay, I'll solve here only. So u of pi by 4 comma pi will be equal to sine 2 into pi by 4, okay, into sine hyperbolic y is pi, so it will be 2 pi, okay, upon sine hyperbolic 2 pi. So this hyperbolic 2 pi will get cancelled, and this will cancel with this, and sine pi by 2 will be just 1. Okay, so answer is 1. Okay, answer is 1, and that makes your option B correct. Okay, thanks for watching.